Hello everybody, I'm Mr. Bahork and today we're going to be talking about squares and square roots. I'm going to start off by talking about squares. What in the world is squaring something? Well, squaring something is multiplying a number. So multiplying a number by itself. So by itself. So that doesn't mean like it's alone. It means like if I have a 7, I want to multiply it by itself. Well, itself is 7. So I want to multiply it by 7. And we know that's 49. Okay, and that's called squaring a number. Okay, there's a shorthand way to write this. We could say, okay, well, 7 squared is 49. And that's the shorthand way to write it. We write this part right here, the 2, we say that's being squared. It's to the second power, as you'll know if you looked at the powers video. Okay, so it's the number times itself. So where does this come from? Well, basically, let's take a look at a number like 3. Okay, if I wanted to represent 3 squared, that's doing 3 times itself, so 3 times 3, or 3 squared is 3 times 3, and that would be 9. Okay, well that makes sense. 3 times 3 is 9. Well, where does that come from? Why do we say squared? Why can't we just say 3 times 3? Duh. Well, if I had a box, or how about just a square, big square like that, and each side of the square was 3 units long. This is going to be a pretty bad looking square. Bear with me here. Okay, so each side is 3 units long. You'll notice that this side is 3 units, and this side is 3 units. And I think you can already see in the picture that there are 9 squares total. So if we have a square, okay, a nice square here with a dimension of 3, to find the area, it's 3 squared, hence the shape square. Oh my goodness. I know, it's super exciting. Try to calm down. So anyways, that's basically what squares are. Now we have some other type of squares that we want to talk about, and this really nice one's called perfect squares. So perfect squares. So what in the world is a perfect square? Well, if you've been working with math for a while, you may realize that, oh, I can square just about anything. I can take like 2.7 and say squared. You can punch it in on the calculator and find out what it is. Well, a perfect square is when we square an integer. It is the square of an integer. So let's start off with a really easy integer. How about, oh, I don't know, 1. Okay, so if I square 1, the perfect square is, well, 1, because 1 times 1 is 1. 2 squared, that's another integer. The perfect square here would be 4. 3 squared, okay, well, that would be 9. So the ones I'm listing here are the perfect squares. Okay, so 1, 4, 9, and we can keep this list going, actually. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared, 64, that's a really bad 6, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. If you are in my math class, those are the perfect squares that you need to know. Okay, I want you to know those. If you're in somebody else's math class, well, enjoy them. Anyway, so those are the list of perfect squares. All of these are the result of squaring an integer. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, blah, blah. It's the first 15 perfect squares. Sweet. That's pretty much all I want to say about squares. So now when you're in math class, though, if you're talking about squares, you're definitely going to want to talk about, of course, square roots, hence the title of the lesson. Let me erase all this stuff. And square roots are really not that bad. If you got a good grasp of what squares are, then you're not going to have much trouble with square roots. So square roots, what is that? A square root. If I can actually write. I haven't used this thing in a little while. A square root is the inverse of squaring a number. The inverse of squaring a number. So if I have, let's say, 4 squared, or 4 to the second power, okay, we know that that's 16. Well, how do I go backwards? What if I start with 16, and when I want to go back to 4? Well, we do something called the square root. You'll notice this is like a pair of inverse operations. If I divide something, to undo that, I should multiply. If I add something, to undo that, I should subtract. If I square something, to undo that, I should square root. And you better believe it, to undo a square root, you have to square. Bingo. So let's take a look at some of the symbols and stuff like that involved with square roots. So you probably maybe have seen this before, especially if you ever play with your calculator. Okay, right here we have what we call the radicand, or radical, sorry. Can't talk to that. It's the radical. Okay. It's a little weird looking. I used to pretend like it was like a Nike check mark thing with a line going, I don't know. But that's called a radical. And whatever's underneath the radical, let's put a nice big variable there, that is called the radicand. Okay, that's the radicand. So whatever's underneath there is the radicand. So let's do a little bit of work with square roots. So let's notice something with these. And this is a really fascinating property of square roots. And I'm not going to get too much into the details, but I think it's really, really cool. So I said that doing square rooting is like inversing squaring a number. So let's say I have the square root of 16. I'm looking for a number times itself that is 16. Well, let's think. Well, that's 4. Okay, well, because 4 times 4 is 16, right? 4 times 4 is 16. It works. Sweet. Now, you might be wondering, and I hope you are, isn't there another answer? Well, yeah, because if I want to find the square root of 16, I'm looking for a number times itself that's 16. Well, wait a second. Isn't negative 4 times negative 4? That's also 16. So the square root of 16 could also be negative 4. So it could be 4 or negative 4. Whoa, this is getting crazy. So what we're going to be dealing with in this class, though, because this video is intended for pre-algebra students. Okay. In this class, we're only going to be dealing with what we call the principal root. The principal root, easy to remember, it's the positive root. So really you get what we call 2 roots, 2 answers. Okay, the square root. We're only dealing with the positive answer. So we're gonna ignore the negative 4, unfortunately. So sorry, sad face. He's ignored. So let's practice a little bit. Let's just say we'll do some square roots, real easy ones, real fast. And I've made a mess of this board here, so let me clear this off. All right, so real easy stuff. Every time you do a square root problem, you don't really need a calculator, especially if you know your perfect squares really well. So if I want to do the square root of 144, well, I'm just thinking, what times itself is 144? What times what is 144? Well, that's 12. And remember, we're dealing with the principal root only, so we're going to say positive 12. Okay, number 2, how about square root of 121? Number times itself, that's 121, that's 11. And I know my perfect squares well enough because I'm taking the square root of a perfect square. So it has to be a nice, pretty integer. About the square root of 81. 81 is a perfect square, so the answer is 9. And just for the heck of it, let's do square root of 25. 25 is also a perfect square, and 5 is your answer, because 5 squared is 25. Now, one thing that kind of throws some people for a loop is, what if I said the square root of 27? Whoa. 27, if you went back and looked, it is not one of your perfect squares. So it's not going to be a nice, pretty number. In fact, the square root of any number that's not a perfect square is actually an irrational number. So it's going to be a long series of decimals that go on forever with no pattern that repeats. You can't write it as a fraction. So square root of 27. Well, what I might ask in this class is I might say something like, well, what 2 integers is the square root of 27 between? So what two integers is the square root of 27 between? And this, it is very helpful to know your perfect squares. The square root of 27 is in between the square root of 25, which we know, and the next perfect square is the square root of 36. So it's in between those two numbers. Well, what's the square root of 25? 5. The square root of 36, that's 6. So that means that the square root of 27 should be somewhere in between 5 and 6. So it's in between the integers 5 and 6. Somewhere in between. And since it's the square root of 27, you'll notice that 27 is closer to 25. So it's probably like a lot closer to 5. Okay, 5 point something. But it's in between 5 and 6. That's where the square root of 27 would be. Okay, let's try another one of those real quick because I like those a lot. What about like the square root of 175? Ooh. Well, just think. What are some perfect squares that are near 175? Well, we got the square root of 169 and the square root of 196. And this is, again, it's very, very helpful if you know your perfect squares, like if you just know them. I know that the square root of 169 is 13. I know the square root of 196 is 14. Okay, well, that means that the square root of 175 has to be between 13 and 14. It's between those two integers. One last thing I want to point out about square roots, and this is a very quick thing. Okay, say I'm taking the square root of a negative number, like the square root of negative 9. If you try to plug that in, or if you even just think about it, you don't even have to plug it in. I'm trying to think of what times itself is negative 9, and they both have to be the same thing. Well, according to my negative rules, I can't do that because I'm trying to get a negative number under here, and I thought only numbers with opposite signs could multiply together to get negative. So that means they won't be the same. If you try to plug it in the calculator, give it an error. It might say non-real answer or something like that, and that's because this would be an imaginary number, is what we call this in mathematics. And yes, that is true, SpongeBob style. Imaginary numbers do exist. So, square root of negative 9, we're not doing that in pre-algebra, so that's imaginary. We use an I to denote that. But you don't have to know that for now. What we can do is if I say the square root of 9 with a negative on the outside. The reason why I can do that is because it's saying the same thing as this. It's saying negative 1 times the square root of 9. Okay, and that can be done because negative 1 times 3 is negative 3. So that would be our answer for that one. All right, I'm Mr. Bork, and that's pretty much all I want to say about squares and square roots today.